This is Basis 3 board that I just bought. Notice that there is a jumper here where you can select how to power your board. Right now, I'm using the external power supply to supply the 5 volts through these wires to this jumper here. And you can also choose to power your board through the USB, which I don't have a USB male-to-male connector right now, so that's why I'm power the board through the external power. And there's another jumper at this side where you can select how to program your board. You have 3 choices. You can program your board through the on-chip called SPI, where basically there is a flash memory, that non-volatile memory on this FPGA, and then the SPI will sort of read the code stored inside that flash and program your board from there. So you don't need external bit stream to write to the board from the PC, because it's a non-volatile on-chip memory. And you can move this jumper to the JTAG, which basically connect from this Type B USB or micro USB. You can program your board directly from there, and you can also choose to use the USB to program your board, which I will not use because I don't have a cable. And right now I put this jumper to the call SPI option, which it will load the whatever code stored in the flash. So when I turn on my board, this is sort of the built-in code coming out of the shape, out of the factory, where you can see there are a bunch of LEDs here where you can toggle this switch and it will turn off the corresponding LED. If you toggle it back, it will turn on the LED. And then there is a 7-segment display here where there are 4 of them. You can display the digits. There are a couple of other interfaces like this FPGA port and some other ADC port here, and I will not go through them one by one because we're gonna touch it through projects. And actually I have a program that I want to program through this micro USB, and I'll do that right now. So the file that I programmed is the Lab 3 Task 4 from one Coursera course. Basically in that task, I implemented a multiplexer basically route signal from these 16 switches divided by 4, and each 4 of these switches constructs a 4-bit binary number, and this multiplexer also has 2 address line, which I mapped to the lower address 0 is this center button here, and then the address 1 is this top button here. So you push those buttons, I actually have 4 options because I have, it's 2-bit address. So I can select to pass a signal from this 4 switch, or signal from, or 4-bit number from this 4 switch, or 4-bit number from this 4 switch, or the last 4 switch. And it's a multiplexer, right? So it select one out of the 4 by using the address here, and then that number represented by the whatever selected 4-bit binary will be passed to the 7-segment display to display the actual digit. Right now, nothing. No, I didn't press any button here, so it's 0, which means that the digits represented by these 4 switch got passed to the 7-segment display, and right now it is showing 7 because I have this 1, 1, 1, and 0. So in binary, 0, 1, 1, 1 is basically number 7. And if I push this force button up, it will become an F, because I have 1, 1, 1, 1 right now. And if I push this thing down to 0, it will display 0. And if we press this center button down, it will display a 2, because my address right now is actually 1, 0, actually a 0, 1, 0, 1, because the button I'm pushing is the lowest bit for the address. And then it is number is reading the 4-bit number from the segment is reading the 4-bit number from the this 4 switch. It's basically 0, 0, 1, 0. So it is a 2 when you press this down, right? And when you press that button down, it's actually 1, 0, which kind of read 1, 2, 3, 4, 5, 6, 7, 8. It read this 4 switch, right? So this 4 switch is a F because it's all high. So it is a F. And the last, if you push this 2 button down, it's a 1, 1. Select the last 4 switch, which is the 8, because this switch is high. It's 1, 0, 0, 0. So that's just a simple function we implemented by the VHDL code. Now let's start talking about the coding part of this project, and as well as how to program the board and generate the bit stream and program the board.